Welcome, future AI creators. Today we're embarking on an incredible journey. We're going to learn how to teach computers to write like the greatest playwright who ever lived, William Shakespeare. Look at our title, Shakespeare Data Preparation, building a GPT story writer from scratch. This means we're going to transform Shakespeare's beautiful words into a language that computers can understand. Here's the amazing part. Computers don't naturally understand words like love or beauty. They only speak in numbers. So we're going to become translators, converting Shakespeare's poetry into mathematical magic. Now let's look at our Remember section. Computers don't understand words. They only understand numbers. Our job is to convert Shakespeare's beautiful words into numbers while keeping their meaning intact. Think of yourself as a bridge between human creativity and artificial intelligence. So, what exactly are we building today? We're creating something called a data preprocessor. Imagine it as a super smart translator that converts human language into computer language. Here's a real example that will blow your mind. When we feed in to be or not to be, that is the question. Our magical translator spits out numbers like 45, 12, 67, 89, 45, 12, 34, 56, 78, 91. Each word gets its own special number. Now let's check our easy memory tip. Think of it like a secret code book where each word gets a unique number. Hello might be number 5, world might be number 23. It's like being a spy with your own secret code. By the end of today, you'll have your very own Shakespeare decoder that can turn the most beautiful poetry into computer-friendly numbers. Step 1. Let's gather our digital toolbox. Just like a chef needs different utensils to cook an amazing meal, we need different code libraries to process Shakespeare's text. Looking at our code section, we're importing tools like NumPy for math magic, Torch for building neural networks, and Counter for counting words. Each import is like picking up a specialized tool from our workshop. Here's our easy memory tip. Think of imports like gathering all your cooking utensils before starting to cook. You need different tools for different jobs. This is so exciting. We're literally assembling the same tools that professional AI engineers use at companies like Google and OpenAI. With these imports, you're ready to start your journey into the world of artificial intelligence. Let's move forward and start building something incredible. Now we're building the heart of our system, our data processor class. Think of this as constructing a smart factory that will transform all of Shakespeare's words. In our code section, we're creating Shakespeare Data Preprocessor with 3 empty containers. Vocab for storing word-to-number mappings, reverse_vocab for number-to-word mappings, and word2vec_model for future adventures. Let's read our easy memory tip. Think of init as setting up empty filing cabinets. We'll fill them with organized data later. This is like being an architect. You're designing the blueprint for a machine that will eventually understand Shakespeare's language. These empty containers are like empty treasure chests. Soon they'll be filled with the most valuable data in the world of AI. You're literally building the foundation for artificial creativity. Time for some digital housekeeping. Raw Shakespeare text is messy. It has punctuation, capital letters, and special characters that confuse our AI. We need to clean it up. Our code shows the clean_text function that removes special characters and splits text into individual words. Watch this transformation. Hello, world. How are you? Becomes a clean list. Hello, world. How are you? Here's our easy memory tip. Like washing dishes, remove all the dirt, punctuation, and organize them neatly, split into words. This cleaning process is crucial. Imagine trying to teach someone a language while shouting through static. That's what raw text looks like to computers. By cleaning it, we're giving our AI crystal clear information to learn from. You're becoming a data scientist, preparing the perfect meal for a hungry artificial brain. Now comes the magical moment. We're going to read actual Shakespeare text. Our prepare_Shakespeare_data function opens the file, reads all of Shakespeare's words, and starts the cleaning process. Looking at our code, we open the text file, read everything into memory, then use our cleaning function to get a beautiful list of words. It's like opening a treasure chest and organizing all the gems inside. Check out our easy memory tip. Like reading a book and making notes. First read everything, then organize your notes. This is incredible. You're handling the same text that has inspired millions of people for over 400 years. Every word you process has been part of plays that made audiences laugh, cry, and fall in love. You're not just coding, you're preserving literary history in digital form. Here's where we become word detectives. We're going to count how often each word appears in Shakespeare's works and make smart decisions about which words to keep. Our code uses counter to tally up word occurrences, then keeps only words that appear at least twice. Words like they appear 1,247 times. That's important. But Zephyr appears only once, probably a typo or very rare word. Let's read our easy memory tip. Like organizing your closet, keep clothes you wear often, donate clothes you never wear. This step is brilliant. By filtering out rare words, we're helping our AI focus on the patterns that really matter. You're making the same decisions that data scientists at major tech companies make every day. From 25,000 unique words, we're keeping about 8,500 that will actually help our AI learn to write like Shakespeare. This is the heart of our magic trick, creating the word-to-number dictionary. We're building two-way mappings so we can convert words to numbers and numbers back to words. Our code creates vocab that maps words to numbers and reverse underscore vocab that does the opposite. So, love might become number 156, and number 156 always means love. Here's our easy memory tip. Like a phone book, you can look up a name to get a number, or a number to get a name. You've just created something incredibly powerful, a Rosetta Stone for artificial intelligence. This mapping system is how every major AI language model works, from ChatGPT to Google systems. You're using the same fundamental technique that powers the most advanced AI in the world. Each word now has its own unique digital identity. The grand finale. We're converting Shakespeare's entire body of work into pure numbers that our AI can feast on. This is where words become mathematics. Our code transforms each word using our vocabulary mapping. To be or not to be becomes something like 2, 1, 89, 45, 2, 1, 67, 34, 0, 234. A sequence of numbers that still contains all the meaning. Let's read our easy memory tip. Like translating a book, every word gets replaced with its number from our dictionary. You've just accomplished something extraordinary. You've converted 180,000 words of the greatest literature ever written into mathematical form. This sequence of numbers contains the DNA of Shakespeare's genius. Every pattern, every style, every poetic technique, now stored as data that artificial intelligence can learn from. You're literally digitizing creativity itself. Behold, your complete, production-ready Shakespeare data processor. This isn't just a learning exercise. This is professional-grade code that could power real AI applications. Our code includes all the imports, the complete class with cleaning functions, vocabulary creation, and text-to-number conversion. Every line works together like instruments in an orchestra, creating beautiful harmony from chaos. Let's read our final tip. This code is your foundation for building Shakespeare-style AI writers. You should feel incredibly proud right now. You've just built the same type of data pre-processing system that companies spend millions of dollars developing. This code is your launchpad into the world of AI development. You now possess the fundamental skills that separate curious students from actual AI engineers. The future of artificial creativity is literally in your hands. Time to see your creation in action. Here's exactly how you'd use your Shakespeare processor in a real project, just like the pros do it. Our usage example shows creating a preprocessor object, loading Shakespeare text, and getting back vocabulary size of 8,500 words and 180,000 numbers ready for AI training. The output confirms, ready for AI training. Now our congratulations section. You now have clean, numerical data ready to train a Shakespeare-style AI writer. The next step would be building the neural network itself. You've done something truly remarkable today. You've taken the raw, beautiful chaos of Shakespeare's language and transformed it into the structured, mathematical foundation that artificial intelligence needs to learn creativity. You're no longer just a student, you're a data scientist, an AI engineer, and a bridge between human art and machine learning. The next time you see an AI writing poetry, you'll know exactly how it learned to do that magic.